We will be talking about work. Ano nga ba yung mga salitang pumapasok sa isipan natin sa tuwing nakakarinig tayo ng salitang work? Or what comes into our mind when we hear the word work? Now, in layman's term or in old definition, we often use the word work in our everyday lives. For example, we would say that getting good grades in school takes a lot of hard work. Sino ba namang ang hindi mag-e-effort ng sobrang effort para makakuha ng mataas na marka or mataas na grado? Others will say that you work on math problems. That's also work. We might also say that when we go to work, that's also work. When we make a sandwich, it's also work. Taking out the trash is too much work. And doing your homework, we can say that it's still work. But in physics, the term work has a different meaning or specific meaning. Work in physics, measure of energy transfer that occurs when an object is moved over a distance by an external force, at least part of which is applied in the direction of the displacement. What do we mean by that? For work in scientific sense to be done, there must be force exerted. So kailangang may force na i-exert and there must be displacement in the direction of the force. So in other words, kung mag-exert tayo ng force sa object, okay, that object must be moved to the direction of the force. Here are some examples. If someone is pushing on a wall with all their might or with all his or her strength, but the wall doesn't move, then therefore we may say that there is no work done. Why? Because the distance is zero. Why zero? When someone is pushing the wall, then of course sabihin natin na nag-exert talaga tayo ng effort or ng force, binigay na natin ang lahat, pero kulang pa rin, hindi pa rin nag-move ang wall, then therefore the distance is zero, so there is no work done. So tulad nga ng definition natin ng work, when we move an object, okay, that object must be moved to the direction of the force that we are exerting. So then therefore, this example tells us that there is no work done. Second, if someone is using force to hold a rock over their head while walking eastward across a field, then there will be no work done or no work has occurred. Why? This is because the force is not in the same direction. Although sabihin natin na nagmo-move ang tao and he is carrying the rock, but the direction is not the same. So, based on the example given, yung taong nagkakarga or nagho-hold ng rock over their head, so meaning yung force niya is papunta sa taas, and then the direction or the distance is going eastward. So therefore, the direction and the force not the same. So we may say as well that this example is no work done. Now, let us take a look at this picture. When do we know if there is work done on an object? Based on our example earlier, or based on our previous example, what do you think is the answer for this figure or for this image? A girl is pushing a chair. Now, we say that work is done when the force and the direction of the motion is the same. What do we mean by that? The girl is pushing the chair forward, and therefore, that chair is also moving forward. So, what do you think is the answer? There is work done. If the object you push moves a distance in the direction towards which you are pushing it, so there is work done. How about for this example number two, or for this image number two? The boy is pushing the wall. No matter how effort you are going to push the wall, kahit anong effort ang ibibigay natin, hinding-hindi pa rin mag-move ang wall. So therefore, the example or the answer for this image or figure is no work done. Why? Because the boy is pushing the force, the boy is pushing the wall and then the wall is not moving. So there is no displacement or the displacement is zero. So there is no work done. If the force you exert does not make the object move. Next image. Take a look take a look at this guy or take a look at this waiter. For figure number 3, a waiter is carrying a tray. The force is on the tray para hindi mahulog ang tray of course, yung mga baso. And he is moving forward or he is walking forward. Now, what do you think is the answer? Remember that the force is going up. He is lifting the tray and then therefore he is exerting force on the tray and that waiter is moving or walking forward. So, it's perpendicular. So, what do you think is the answer? No work done or work done? There is no work done. Why? There is no work done if the force you exert does not make the object move in the same direction as the force you exerted. So, sinasabi dito na dapat when we exert effort on an object and when we move, dapat the same yung direction nila. If we are moving forward and then we are pushing the object forward, of course, the object will move forward. So there is work done. I'll be giving you another examples. And this time, I want you to identify the direction of the force and I want you to also to identify the direction of the motion. And after which, you're going to tell me or you're going to tell yourself if that image is doing work or is not doing work. Example number 1. The girl is pushing the box. I think we have given that example earlier or on the previous slide. Now, I want you to identify the direction of the force. Is it moving forward or is it moving backward? The girl is pushing the box. Of course, the box will move forward and then the motion or the force or the direction of the force is forward. And then the direction of the motion is also forward. So is there work done or no work done? Yes, there is work done. Next picture, the girl is carrying a backpack or backpack. Now remember, the girl is lifting the bags. If the girl is lifting the bag, what is the direction of the force? For the girl to be able to lift the bags or the bag, he needs or she needs to pull. The girl is carrying a bag at his or the girl is carrying a bag on his back. Now, what is the direction of the force? Upward. Why? She is exerting force upward so that she would be able to carry the bag. And he is walking. So what is the direction of the motion? Forward. Is there work done or no work done? Of course, there is no work done. Next picture, the girl is lifting the grocery items. What is the direction of the force? She lifts up the grocery items and then the force also going up. So then therefore, the grocery items moves move forward and then the direction of the motion also move forward. So the answer is work done. The next one is the girl is carrying the grocery items while walking. What is the direction of the force? Force up. Then what is the direction of the motion? She is moving forward. So the answer is no, or we may say that there is no work done. So that's how we are going to identify, or that's how we are going to define work in terms of physics. Work, or there is work done when we, or when the force is applied to the object, causes the object to have or to move in the same direction as the force applied. So that is what we meant by work in physics or in science. Work in physics, of course, when a force acts on an object to move in some distance from the starting point, or we called it as displacement. Work is calculated as the force times the distance. The equation of work, or formula for work, is big letter W equal to big letter F times D, or small letter d, wherein we may say that W is work, F is force, or the Newton, or big letter N, and D is the distance, or small letter m, or the meters. Newton meter, or the Nm, or a joule is the unit that measures work. Example problem: a baseball player throws a ball with a force of 10 Newton, or 10 m. The ball travels 20 meters, or 20 m. What is the total for work? Our formula is big letter W equal to F times D. What is our F, or what's our force? 10 Newton. And what is our distance? 20 meters. Now, what we are going to do now is we are going to multiply 10 times 20. So the answer is 200 Newton meter, or 200 Nm, or 200 joules. Sometimes we can also write 200 big letter J. Next example, a teacher applies a force on 50 Newton, or a teacher applies a, another example, a teacher applies a force of 50 Newton to move a student's bag 10 meters. How much work is done? What is our formula? Of course, we write W is equal to F times D, and then the force is 50 newtons, and then the distance is 10 meters. So, we multiply 50 times 10. The answer is 500 joules.